All right, we're going to do section 8 for trig substitution. I have 5 examples. These are the longest problems we have. They take time. It's one of my favorite sections just because of the amount of stuff you use, the amount of identities. You may disagree with me at first, but I think you all get there. You're using a lot of skills that you've learned. What we've had a problem with is we can't take these integrals with any other techniques. Like we would bring this up and try to do substitution, but you're missing the derivative inside. You can't do substitution if you don't have the du. So you need du. So typically it's done with radicals. Some examples I always have all my stuff at the bottom, and it could be top and bottom. My 5th example finally does that. But usually when you have a radical, and like how do you clean it up? So what we do is we do trig substitution. Now these identities can be written in many ways. Like I could write sine squared as cosine squared minus 1, sine squared is 1 minus cosine squared, and so forth. But these are the main three we're going to use, okay? We're going to either substitute sine, secant, or tangent. So we're going to substitute on this side to get this side. Now I want you to notice the difference between those 3 identities. Look over here on the right side. All right, and this is how, instead of memorizing what to do, we're going to use our brain. In this one right here, it's 1 minus, the trig function's in the back end. So your variable's in the back end, and it's minus. This one, your variable's in the front end, and it's minus, and this one's plus. So I look at the problem, and depending on where the variable is in the front end, then I'm going to substitute with secant, because I know that I want it to look like secant squared minus whatever, okay? So this will take a few problems, and you'll get the hang of that. So what I'm going to do is I'm going to substitute x equals, and we'll just use theta for the trig functions. So what you pick though, I want to clean up the radical. So I would have to pick 3 secant theta. And here's why 3. Because when I square it, I'll get 9. I want to get the same number I have here. So if that was a 16, I would pick 4 secant theta. All right, so I let x equals 3 secant, and I'm going to take the derivative. Dx, and the derivative secant is secant tangent. All right, and we're going to substitute. We're going to replace the x's and dx's with secants, and it's a little backwards feeling than the u du, right? We're not trying to switch to u, so we're going to replace all the stuff with all the x's with secants, 3 secants, and all the dx's with 3 secant tangent. So when I do this replacement, dx is on the side or on top. It doesn't matter where I write the dx. So we'll just put on top 3 secant tangent. So we took care of that. Inside the radical, I have 9 secant squared minus 9. So it looks like I made the problem much more difficult, right? You're like, whoa, that looks like it's a lot harder. Well, this is going to clean up nice. And so I usually like to do that kind of off to the side. I'll usually, on a problem, obviously I have this one in the way right now, but I can kind of do it here. I like to clean this off to the side, showing you what we could do. So I made it the same number, so now I can factor out that 9, and we know that secant squared minus 1 is tangent squared. So this is radical 9 tangent squared. And I know the square root of that. So what we're doing is we're trying to put in something that's a perfect square so we can get rid of the square root. And that's what we just did. So 3 tangent. So that replaces 3 tangent. So now I have 3 secant tangent over, and again, this is here, and the square root of that is 3 tangent. All right. And those cancel. So now I have just the integral of secant. And we learned the integral of secant. Natural log of secant plus tangent. And people are like, hey, we're done. Oh, no. We started with x, we ended with x. We have theta. So what do we do? Well, here's where the triangles I taught you guys how to draw come into play. So now we got to do a little thinking. We're almost done. We know the x equals 3 secant. Solve that for secant. Let me write it right above it here. Secant theta is x over 3. So we're going to do a theta triangle. Well, secant is x over 3. Remember, secant is hypotenuse over adjacent, opposite of cosine. Can we find the third side? Remember, we practiced this in chapter 5, is that we found the third side. This third side would be radical x squared minus 9. Remember, it's the hypotenuse squared minus the leg squared. So radical x squared minus 9. So now I have the three sides of the triangle. And you're like, well, why do I need those? Because I have trig functions. So my answer is ln of secant of theta. Well, I know secant theta was x over 3. And what's tangent of theta? This is why I did the triangle. I can do any of the 6 trig functions now. Tangent of theta is radical x squared minus 9 over 3. Okay. Keep my absolute value. And now we're done. So that's how you do the different, the trig substitution, and how you get rid of the trig function at the end. And that's what we do. Okay. Now, this problem can be cleaned up. You could comment number 3, and then remember, if it's division, so you can write it as a minus. Well, 3 is a constant, so it can be absorbed into the constant. It's a long story, but you could actually absorb that 3 into the constant by doing some math work, okay? So we can do that in class and see what that looks like. All right, so now let's look at this next one. Well, I want to pick x equals, I got to do what? Well, it's plus, so it's going to be tangent for sure. But, ooh, what would I multiply that by? Well, it's going to be a half tangent. Because when I square that, I'll get a 4 tangent squared times 4 gives me 1. I want to match that number on the right. Okay? So, dx is 1/2 secant squared. Trig tangent secant squared. All right, let's substitute. So I got 4 times that squared, which is tangent squared over 4. So you see those 4's cancel, so I have tangent squared plus 1. Well, I don't have to do much work. Tangent squared plus 1 is secant squared. And what's the square root of secant squared? Secant. So we get 1/2 secant. Now, they're not always going to end up with secant. First couple problems I picked had secant. I need to change my notes one day. So the integral of secant is ln secant plus tangent. And now I got to do, if I solve this for tangent, I get 2x. Multiply both sides by 2. So then when I do my triangle, tangent of theta is 2x over 1. Opposite over adjacent is tangent. You have the 2 legs of a right triangle. You have to add them. 4x squared plus 1. Now I have all 3 sides of the triangle. And then secant is hypotenuse over adjacent. So, and tangent is opposite over adjacent, 2x plus c. All right. So there's the first couple. I got a few more to go. I'll start, I'll just do a part 2 video of that one. So this one I'll refer to as part 1, and then I'll set up and do another video.